Hello.
Hello, I'm so sorry
No,
about
it's
the
okay.
delay.
Yeah, it's
Yeah.
yeah. I just got back too, so it was good for me too because I was stuck in traffic.
Okay.
I was driving and I just yeah
Okay,
yeah.
that's good. For me, I got hungry and I was like, how am I gonna make food in time?
Oh yeah. No worries. What did you eat? What did you make?
I'm making spinach tortellini from Trader Joe's and I'm
Oh,
putting it into the Trader Joe's pesto basil sauce. It's really good.
it's really
And
good.
I sauteed some mushrooms and spinach with it, so it's really yummy.
Wow. That's good. That's good. Study snack.
Yeah.
hmm you said you wanted to go over nomenclature.
Yes, please.
Uh-huh.
Yeah, it's like I was reading OChem as a second language. I got about 60% done with that chapter, and it's
Yeah.
just like really confusing.
Do you have an iPad or tablet that you could like write on, like that you take notes on?
Yeah, I do. I'm just
hmm
draining pasta right now.
Yeah,
I'm
you
so sorry.
could join the Zoom from the iPad and then you can share a screen and annotate it, or we could use the whiteboard and then we could go work through problems together and I could like
Okay,
show
yeah.
you. Yeah, I think that
Yeah,
would work.
we can do that. Can we do that in a bit?
Yeah, we could do it in a
Okay.
bit. Uh-huh. Okay.
Okay.
So, nomenclature, you haven't learned about alcohols yet, right? Like that functional group, or like you just learned about substituents like bromo, chloro, iodo,
Yeah.
or like the common names, right? I'll give you the general guidelines of what I like to do, right? General guidelines. So the very first thing that I like to do is find my highest priority group and find the longest chain based on the highest priority group, right? But in 118A at this point, we don't have to worry about that because you just learned about alkanes so far, right? And haloalkanes for nomenclature
hmm
and like the common names. So for at this point, I would look at the longest carbon chain, right? And then from there, once I find the longest carbon chain, then I find the substituents. And then once I get the substituents, I name them in alphabetical order, right? But there's a lot of like different rules to that. There's like common name substituents. There's IUPAC substituents, and there's like di, tri, tetra, right? So let's look at an example here. Let's say we have, let's start with something simple. Let's do something um, like this right here. How would you name this structure over here?
For that one, I would count the longest carbon chain. So that's one, two, three, four, five, six, 7 carbons. So I know that there will be hepta.
Uh-huh. Right. One,
Um,
two, three, four, five, six, seven. And did you number it from left to right or right to left?
left to right.
Left to right, right. Correct. So let's do that. One, two, three, four, five, six, seven. Where this is our main chain right here. So it's gonna be heptane as our base name
hmm
right here. Correct. Okay. Okay. Now our substituents are gonna be this and this right here. And how would you name those in the nomenclature, the name?
Um, so that one has 1 carbon sticking out, so that I know that's a methyl.
Mm-hmm.
And then the one that has two is an ethyl.
Right. And we would identify that using the carbon that they're coming off of. So the methyl group would be 2-methyl. The ethyl would be 4-ethyl. And you put dashes between numbers and letters. That's when you put dashes in nomenclature, right?
Okay.
And once you have this set of substituents, how would you put all of this together here to get the full name?
I'm not sure about that part.
Uh-huh. So for this part right here, once we have our base name and the substituents, then we look at the alphabetical order. Um, like we're gonna compare E and M. E comes first before M. So we're going to name it 4-ethyl-2-methyl heptane, like that, right? So that's gonna be the full name. This is the base name, which indicates our longest parent chain. And then once we have our substituents, we then put it in alphabetical order. We don't put it in number, right? Like 2 is the lower number than 4, but we put ethyl first because E comes before M in the alphabet, right?
Yeah, that makes sense.
Okay. So now let me give you a little bit trickier one. Let's try something like this right here. Okay. Okay. Let's try this right here. Or actually, let me do this. This and that. There you go. Okay, how would you name this structure here?
So for that one, I know there's 1, 2, 3, 4, 5, 6 carbons.
So this is the trick right here. This right here looks like the longest chain, right? Because we're used to seeing the longest chain in zigzag in this direction, horizontal, right? But we see that there is a longer chain where we go 1, 2, 3, 4, and if you go up here, 5, 6,
Oh yeah.
7. That's the longest chain right here, where the highlighted molecule right here is the main chain, and then these circled substituents right here are gonna be the substituents, like that, right? So this one here is also gonna be heptane. How would you name the substituents here, like with the numbers?
So I know that there's a methyl sticking out from 2, and there's a bromo sticking out from 2. There's another methyl at 3, and there's an ethyl at 4.
Correct.
So I'd write those down.
Right.
And then put in ABC order.
Right, write it down and put in ABC order. But you notice how we have 2 methyl groups, one on carbon 2 and one on carbon 3. We would put them down as 2, 3 dash dimethyl. Right, that means that di is 2. We have 2 methyl groups, one for carbon 2 and one for carbon 3, like that. Right. There's a bromo on carbon 2, so we're gonna put 2 dash bromo. There's an ethyl at carbon 4, so we put 4 dash ethyl. Now there's another trick here. When you have like di, tri, or tetra, like with whatever substitutions you have, that does not count in alphabetical order. So I'm gonna underline the letters that do count in alphabetical order, which is gonna be the M in methyl, the B in bromo, and the E in ethyl. Okay. The D here does not count in alphabetical order. Now, how would you put all of this together if you were gonna put it together in ABC order here?
Bromo goes first, then ethyl, then dimethyl, then heptane.
Yep. So 2 dash bromo dash 4 dash ethyl dash 2 comma 3 dash dimethyl heptane. Okay, now that's good. Let's go over the common name for substituents. Common names of substituents. Okay. Let's also give you the IUPAC name. So this squiggly line here is just gonna show you a fragment, which is a substituent, right? Let's also do this. Let's also do this. Okay. So you know how in this structure here, this ethyl is a substituent right there. That could also be represented like that. This squiggly line is showing that this ethyl group here is coming off of the main chain. Right. If we look over here, we're saying that this is a substituent coming off of a main chain. Because let's say this is the main chain of a molecule right here. This right here would be a substituent of this main chain right there, right? But we don't know what the main chain is. Like, this is just a common substituent that we see. Do you know on the top of your head what is the name of this substituent?
Isopropyl.
Yep, isopropyl, correct. Isopropyl. So that's the common name of it. A way that you can think about it is like this. How many carbons do you think of when you see prop, like propyl or propane?
There's 3.
3, right? So in total, there's gonna be 3 carbons. 1, 2, 3 carbons. So that's where the prop comes from isopropyl. When you see iso, there's gonna be 2 methyl groups coming off of 1 carbon, right? So we see that here. This is the 1 carbon here where there's 2 methyl groups coming off of it, right? Iso, it's isolated. The 2 methyl groups are isolated. And propyl is just indicating 3 carbons in total. 1, 2, 3. So that's the common name of that right there, right? And the I in isopropyl does count in alphabetical order, right there, like that. Now let's practice the IUPAC nomenclature. Let's say this right here is a substituent. What is the longest carbon chain of this substituent? If this right here is carbon 1, it's gonna be 2 carbons long. So we see at carbon 1, right, there is a methyl group coming off of carbon 1. So we would number this as like whatever number it is coming off, like of the main chain, dash parentheses 1 dash methyl, because we see a methyl coming off of this substituent, which is going to be ethyl, right? Because it's 2 carbons long, and we put a YL here, ol, because that YL represents a substituent, right? And then we put parentheses, and then we just continue on with the name like that. And I'll give you practice problems with this, but this is the full IUPAC name right here. Like, you could either use isopropyl or you could use 1-methyl ethyl, right? 1-methyl ethyl is the full IUPAC name. Isopropyl is the common name, like that. Does this make sense? Of why this is 1-methyl ethyl?
Yeah.
Okay, that's good. Have you seen this substituent before?
I see 1, 2, 3, 4 carbons. And then so I think it's the butane one. Yeah, tetrabutane or.
So there's 4 carbons total. 1, 2, 3, 4. But that's gonna be butyl because YL here represents a substituent, right? Like isopropyl.
Oh, right.
YL substituent. How many groups are coming off of this carbon here? Let's see. I'm gonna circle it like that. How many groups do you see coming off?
There's 2, 1 methyl and then 1 ethyl.
Yes, 2 groups, 1 methyl and 1 ethyl. So we're gonna call that sec-Butyl. Sec meaning secondary, 2. Right. So 1, 2, like that. Okay. But when we name this substituent, the S in sec does not count. We're looking at the B in sec-Butyl when we're like ordering the substituents in alphabetical order.
Okay.
Now I want you to practice naming the full IUPAC nomenclature the same way as we did in this previous example here. Like, let's say this is carbon number 1. How would you continue to name this in full IUPAC
nomenclature? I think it would be 1 sec-Butyl.
1 sec-Butyl. So this right here is the sec-Butyl coming off of whatever carbon this is, right? We wouldn't call that 1 sec-Butyl. Let's say this is carbon 1 and this is carbon 2, carbon 3. And this is the longest chain of this substituent, right? This overall thing is a substituent, but this is going to be the longest chain of that sec-Butyl, 3 carbons long. And we see there's a methyl group coming off of carbon 1, right? So this number here represents like whatever number it is on the main chain. Dash, we put parentheses because this is a complex substituent. There's a methyl group coming off of carbon 1, so that's 1 dash methyl. And then because the longest chain is 3 carbons long, we're going to use propyl, like that, and then we continue with the name, whatever is else in the name. So one methylpropyl is gonna be sec-Butyl, like that. Any questions on how I got that?
So we have the one because there's only one. It's on the number one, right?
The methyl group is on number 1, right?
And then it's a methyl coming out, and then
right.
there is a propyl.
A
Oh,
propyl.
because it's a 3.
Yeah, it's 3. It's 3 carbons coming out of the main chain. Like we don't know what the main chain is. It could be any main chain, but if this is the entire substituent and we're trying to find out the longest chain of the substituent coming off of the main chain, the longest chain is 3 carbons long. 1, 2, 3.
Okay.
Like that, right? Okay. Now let's try this one. Do you know the common name of this substituent right here?
That one has 1, 2, 3, 4 carbons.
Yep,
So
4 carbons.
Is this one the tert-Butyl?
Tert-Butyl, yep. Tert-Butyl.
Tert-Butyl.
Right.
Okay.
Because the butyl comes from the 4 carbons coming out of it, and if we see how many branches are coming off of this carbon right here, we see 3 branches. So that's the tertiary part, like for tert-Butyl. Right. So the common name is gonna be tert-butyl. But in alphabetical order, we don't count the T in tert. We count the B in butyl. That's the one that counts in alphabetical order. Okay. Now let's say that this is the main chain right here. What's the longest carbon chain of this substituent coming off of the main chain here?
Would it be 2?
Yeah, it would be 2. 1, 2, and that's the main chain right there. How many substituents do you see coming off of this substituent right here?
There's 2.
There's 2. Yes. So, and those are 2 methyl groups. And you notice how they're both on the same carbon?
Yeah.
How would you name that complex substituent now? Like how would you name this here? Like let's say this is the number dash parentheses, because this number here represents a number of a carbon in the main chain. This parentheses here represents a complex substituent, which is going to be this right here. Now we're gonna name the complex substituent here.
Well, would that be the 2-methyl thing or?
So what carbon is coming off of
It's coming off of 1. So
right.
1 dimethyl.
Yeah, one dimethyl. We have to put 1 2 times because we know that it's a dimethyl since there's 2 methyl groups coming off of it, but we have to put where the methyl groups are coming off of, and they're both coming off of carbon 1, so we put 1 1 right there. Because it could have been like 1 2 dimethyl. Like we have to specify where each methyl is going to. Right? And in this case, each methyl is going to carbon 1. If we look at the previous example over here, you know how we had 2 3 dimethyl?
Yeah.
We also had 2 methyl groups, but one is going to carbon 2, the other one is going to carbon 3.
Okay, yeah, that makes sense.
Right, okay. So we still have to put 1 1 dimethyl, and we don't put ethane, right? Like ethane, because this is not the main chain right here. This is a substituent. And what does a substituent come off like end as?
With the YL?
Yep, the YL. So it's gonna be ethyl, not ethane. Like that. And in parentheses to finish off the complex substituent, and then we continue naming the rest of the structure. Like that. Okay. Any questions on this part?
I'm confused on the ethyl part.
So the ethyl part here is the longest chain of the substituent. It's 2 carbons long. Like this whole complex substituent here is 2 carbons long. 1 2, right? But we don't put ethane because this is not the main chain. right? So an example would be something like this. Like if I have this structure and I have this right here, the longest chain for this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons long. That's the main chain. And what would the suffix of the name be if this molecule is 9 carbons long?
For that molecule, the suffix name, it's gonna be the non one.
The nonane, nonane.
Yeah. And then all of the parent ones, they end with ane at the end.
Yep, they all end with ane if the main chain is an alkane. Later on, you're gonna learn that, especially when you learn about alcohols, it's gonna end with ol. But for now, you haven't learned about that yet. It's all gonna end in ane. Ane for alkane. If you have an alkene, it's gonna end in ene. If you have an alkyne, it's gonna end in ine. But for now, it's gonna end in ane for this part of the course. Right. Okay. Now we see one complex substituent here coming off of carbon 4. And this complex substituent here is what is the common name of that substituent on carbon 4?
That one is it has a 1, 2, 3, 4. It's the tert-butane.
Right, it's tert, but we don't say butane.
A butyl.
Yep, tert-Butyl.
Because
right.
it's the substitute.
Right. And there's no other substituent to order in alphabetical order, so we put 4-tert-butyl nonane. You might also see 4-t-butyl nonane, like that, right? But that's using the common name. If you want to use the full IUPAC name, right? How many carbons long is this complex substituent? Like, what's the longest carbon chain?
It's 9.
The 9 is the main chain, but now we're gonna focus on this complex substituent.
Oh, 2.
2, right? 1, 2. How many substituents do you see?
I see 2 coming off of that.
On which carbon?
Carbon number 1.
Carbon number 1, right? So we would put 4 if we use complex IUPAC nomenclature, because the complex substituent here is coming off carbon 4 dash parentheses. And how would you name this entire thing now in full IUPAC nomenclature?
I would put 1, 1 dimethyl, and then ethyl.
Ethyl. Why can't you put ethane?
Because it's not part of the parent group, it's a substituent.
And for substituents, we put YL, right? And why do we put eth instead of prop? Like propyl.
I'm not sure about that.
So eth represents how many carbons?
2.
2. And what's the longest chain of this substituent?
It's 2.
2. Yep. So that's why we put eth and not prop, because this substituent here is not 3 carbons long. Like the longest chain is not 3 carbons long. If we put propyl, then there would have been an extra carbon right there.
Okay.
Right. Okay. And then we put nonane like this right here. Okay. Now I want to give you one more problem here before we move on to want to try doing a Kahoot on alkane nomenclature. Okay. Okay, try naming this structure over here.
I'll start by numbering it. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the longest chain.
Going left to right or right to left?
Left to right.
Left to right. So if we go left to right this way, 1, 2, 3, 4, our first substituent is gonna be on carbon 4. But if we go right to left, 1, 2, 3, our first substituent hits carbon 3. Right. So we want to name our molecule in a way where we hit a substituent in the lower number. Right. So we're gonna number it from right to left this way. 1, 2, 3,
Oh, okay.
4, 5, 6, 7, 8, 9, 10. Because going this way allows the first substituent to be on the lower number, which is 3. If we did it this way, it would have been carbon 4, which is higher. Right. Where these would be the substituents. How would you label these substituents here? Oh wait, first, what is the suffix of the whole entire molecule if it's 10 carbons long?
It'll be decane.
Yep, decane, correct. Decane. Now, how would you name the substituents here?
So I would first, like, if this was the exam, I would like probably put labels on the side and define them. So I know that it's dichloro. So I know I'm probably gonna name that 4,6 dichloro. I know for the bromo, it's gonna be 3 bromo. And then for the one at the top, I would probably find the longest chain. So there's
right.
1, 2, 3.
And
then I see that there's 2 metals coming out. So it would be 7 because that's the starting point. Then parentheses. And then I put what's on the inside, which would be 1, 2 dimethyl. And then that pink strand right there is an ethyl.
Ethyl. So how many carbons?
Sorry, no, mind. There's 3 carbons. It's a propyl.
Yeah, propyl, and that is not any of the 3 common substituents that we talked about, right? We see isopropyl, sec-Butyl, tert-Butyl. This right here was not any of them, right? So if you don't see that, you can name it anyway with the full IUPAC like this, right? Now I want you to put it together and put it in alphabetical order here.
Okay. So I know that decane will be at the back.
You're right.
I know I'm not going to use di. I'll use, and so I'll start with 3 bromo.
Yep.
Then 4,6 dichloro.
Because we're counting the C there in dichloro. Correct, and we'll put dash between numbers and letters like that. Nice.
And then I would put the very last one at the between them two.
Yes.
So yeah.
And for this one, the M counts for dimethyl ethyl propyl.
So I kind of noticed that it's only when they're referring to a number it doesn't count. Like when they say tert kind of refers to 4. I think I'm not sure.
Oh, but... tert. Yeah, because there's gonna be like 3 branches coming off of it, like 1, 2, 3 for tert. And then this is the 4th carbon here, that carbon that is holding those 3 branches like that, right? Yeah.
So anything that has like a numerical suffix, you don't count that for the ABC order.
Yeah, whatever has a numerical suffix, you don't count, like sec or tert, right? Iso, you do count iso, right? This is gonna be the full name for that. If you have a ring that is a substituent, then you would name that as cyclopropyl or cyclobutyl, something like this. So if we have that, and then like something like this, right? This is gonna be 1, this is 2, this is 3, this is 4. Why did I number it right to left instead of left to right here?
I think it's because like the triangle is cyclopropyl, I believe.
It's cyclopropyl, right?
Yeah, and it's like the more special one. So yeah, I guess organic chemistry thinks it looks cooler, so it's from that side.
Oh, right. So it does look cooler. It looks special, right? More so than the methyl group, but they're actually equal in priority in nomenclature.
Oh, okay.
Right. There is a very important rule here. If they're equal in priority, then you look at the lowest number. Like what direction will give you the lowest number substituent first, right? You notice how when we go right to left, our first substituent is carbon 2, which is this cyclopropyl. If we went left to right, like 1, 2, 3, 4, 5, our first substituent would have been on carbon 3. And we don't want that. We want the lowest substituent on the lowest number. Like we want the substituent on the lowest number possible. Right?
Okay. Yeah, that makes sense.
Yep. So this overall would be let's say pentane would be the suffix. And then on 2 we have a cyclopropyl. And then on 3 we have a methyl. The C in cyclo does count. Right. So we will name this 2 cyclopropyl -3 methyl pentane. Does that make sense?
Yes.
Okay. Now, the reason why the ring wasn't the main chain is because we had a branch that is longer carbons than the ring. The ring is only 3 carbons long, but we have a branch that's 5 carbons long, like that. Right?
Okay.
But we can have a ring that is the longest chain. Let's say we have something like this, and we want to name this right here. How would you name this right here?
For that one, the more special one would be the second, I think. The second from the left.
Oh, second from the left. This one right here?
Yeah.
Right. So let's see. 1, 2, 3, 4, 5. So all of these have equal priority. Right? If they all have equal priority, we want to number it in a way like that has the substituents on the lowest number possible. So if we number over here, that's good. That's right. But do you want to number it clockwise, or do you want to number it counterclockwise? Like, do we want to number it 1, 2, 3, 4, 5, 6 this way?
The other way around.
Oh, this way right here? 1, 2, 3,
yeah,
4, 5, 6?
Counterclockwise.
Counterclockwise. So if we number it counterclockwise, notice how our substituents will be on carbons 1, 5, and 6. Like 1, 5, and we have 2 substituents on 6 right there. If we number it clockwise, 1, 2, 3, 4, 5, 6, our substituents will be on carbons 1, 2, and 3. Which one looks better to you? Which one follows the rule?
The second.
The second one, right? Because it has a lower number. We want substitutions on the lower number possible for each name.
Okay.
So we're gonna go clockwise because that allows our substituents to be on the lower number possible.
Okay.
Right. Okay. Now, if I circle these substituents here, how would you name this entire molecule? If cyclohexane is the suffix, cyclohexane.
I would do 1 methyl for the first one that I see.
Yep, right.
I would do 3 chloro. 2 bromo. And then I see a 2 ethyl.
Yep. Okay. These are the list of substituents we have. Now we gotta rank them in alphabetical order. What would go first?
The bromo,
yep.
Then chloro, then ethyl, then methyl.
Correct. So 3 chloro dash. Oh wait. Bromo will go first actually. 2 bromo. 3 chloro. 2 ethyl. And then 1 methyl. And then I don't put a dash between letters and letters. Like, this will continue on from here. Right. Okay. So that's the name of that whole structure. Are you ready to try a Kahoot on alkane nomenclature?
I wanted to ask a question.
Yep.
Is there space between methyl and cyclohexane?
No space. No space between methyl and cyclohexane.
Okay, just no dash, right?
No dash, right. There's no dash.
Okay.
Yep. That's a good question. Do not put a space between methyl and cyclohexane. Yeah. Okay. Like that. That's good. Okay. Yep. This is a long name right here.
Okay.
Okay. Let's do Kahoot. I think I made this Kahoot based on like Levin's quizzes as well, so this will be helpful for you. Like, this is when I like tutored at the ATC. And I just used like previous practice or like my quizzes. Let's see, my Kahoots. 118A, alkane nomenclature. Okay. Okay, here's the Kahoot.
And 5.8, 2002, 22.
Mm-hmm.
Also, I have a question. When you're tutoring me, do you hear me chewing sometimes when I'm eating food?
Oh no, I don't hear you chewing. It's okay.
Okay,
It's
that's
okay.
good.
Yeah,
I get a little scared about that.
yeah. No. I don't mind. Yeah. Mhm.
It looks like that one classroom in the TLC second floor.
Mm. I want classroom on TOC second floor.
Yeah,
Dang.
it looks like the same thing.
Yeah.
So 8, 9, also, oh, 1, 2, 3, 4, 8, 1, 2, 3, 3 comma, and then 1, 4, 5, 6, 6. Okay.
Oh, nice. You got it. Wait, can you hear me?
Yeah.
Okay. That's good. So it's 3 bromo, 6 isopropyl nonane, and you numbered it correctly, from right to left. Why
Mhm.
can't you number it from left to right?
I originally did do left to right, but I changed it to right to left
Uh-huh.
because I saw that bromo came first, and I
Yes.
thought they have equal priority.
They have equal priority. Halogens and alkyl groups, alkyl meaning hydrocarbon chains or R groups,
Hmm.
have equal priority. So if they have equal priority, you want to look for the direction where we hit the first substituent first in the lower number, right?
Okay.
If you numbered it from left to right, you would have gotten different answer. Right? Okay, next one.
Okay. So, oh, this was kind of tricky. 1, 2, 3, 4, 5, 6. That's a 5 shape. They're all pensate. Oh no.
So for this one, you put number 1 as fluoro, right? For the fluorine.
Uh-huh.
But if you did it like that, you would have to go 2 clockwise or counterclockwise, right? So let's try that. 1 on fluoro, 2 on, let's go clockwise on the bottom isopropyl group,
Uh-huh.
right? And then 3, 4, 5. The other isopropyl group would have been on carbon 5,
Oh.
right? Like
Okay.
the one that you chose, 1 fluoro, 2, 4 diisopropyl. That's saying, let's see, 1, 2, 3, 4. Yeah, like on carbon 4, like that's hydrogens. There's no alkyl group there, right?
Okay. Would it be right if it was 5, or would it still be the green one because the numbers are smaller on
Yeah,
it?
it would be the green one because the numbers are smaller,
Okay.
right? So you would start number 1 on the top or bottom. It doesn't matter here.
Okay.
And then you would number in a way where fluorine is number 2.
Okay.
That was a tricky one.
Okay. So 1, 2, 3, 4. That's an oct. Um, is it none of them? Because it's a octane, right?
Cycloalkane. Oh, that's a typo. Think all of them are cyclooctane instead of cyclohexane.
And the best weight could also be starting at equivalent, so there'll be 1, 2, 3, 4, 5, 6, 6.
Another tip that I have for you is like once you have number 1, you want to look for the other substituent, the second substituent, in the lower number possible as well. So if you have 1 and 1, that's good. 1 and 2, that's good. Like 1 1 would be better than 1 2. Yeah, so this one, let's see here. 3 tert-Butyl. Okay, and then you numbered 1, 6 dichloro. 1 2 3 4 5 1 5 diethyl 6. Yeah. Green 3 tert-Butyl. 1 6 1 2 3 4 5 6. Yep. 1 6 dichloro. 1 4 diethyl. Oh, very close, very close. So you numbered it the same way as the correct answer. Like you numbered number 1, the top left corner with the ethyl and the chloro, right? And then you numbered it clockwise.
Yeah.
That's good because our 2 substituents are on the lowest number, chloro and ethyl, right? We want the most amount of substituents on the lower number possible, so that's good. But it's gonna be 1 5 diethyl, not 1 4 diethyl, because if you numbered it like number 1 there, numbered it clockwise, 1 2 3 4 5, that's where the second ethyl group would hit right there.
Okay.
Right. Okay. Does that make sense?
Yeah.
Okay. Nice. Okay. The answer choices kind of give you a hint, because I think when you first saw this, you thought the ring was the main chain, right? Like you thought it ended as cyclohexane.
Yeah.
Yeah, me too when I first saw this, but you notice how all of them end with nonane. That gives you a hint that the longest parent chain is in a branch, and it's 9 carbons long.
Okay. 1, 2, 3, 4. 9. Wait, 1, 2.
And then whatever looks like a substituent to you might be part of the main chain, so be careful there. Like it could start on the top or the bottom.
Oh wait. Okay, I see that now. Wait, 1,
Yeah.
2, 3, 4, 5, 6, 7, 8, 9. Oh, okay. 1, 2, 3. So it's 3 cyclo. Okay. 4 is the ethyl. Okay. And then 4, 5, 6 is methyl. Okay. Oh no! I think I got logged out, but I choose the yellow circle.
The yellow one? Okay, 3 cyclohexyl, 1 2 3 4 4 ethyl, 5 6 6 methyl nonane. Yeah, that should be correct. I think you could log back in, like with the game pin on the bottom, and then choose the answer. Yeah, but that should be correct. That should be correct.
Okay.
Nice. Let's go.
Ooh, okay. This one. It's 1 2 3. Yeah, 1 2 3 4 5. Okay. So it's pent. 1 2 3. And the 3 is hollow. And 2. So on the 2 we have 2 2. Okay. 1 2 3 4. And on the 4 there is 1 2 3 4 tetra. Okay. Oh, that one.
Nice.
Yay.
A common mistake that students make is that, notice how when you look at it, you see two
Hmm.
butyl groups. So
Yeah.
they try to choose tert-Butyl as an answer. So they think that there's only one carbon long, which is the center carbon, and then the tert-Butyls are coming off that center carbon. But that's not correct. The main chain is 5 carbons long, going from left to right or right to left. It doesn't matter because it's symmetrical. And then you
Hmm.
have like the substituents from there.
Okay.
Nice.
Okay. So 1, 2, 3, 4. So. Okay, then I would probably do that way. So that's 1. 1. And 1, 2. Okay. So start out with that one. So 1 apple, 1, 2, 3 ethyl. So this 2 is diethyl. And then 2 is iodine. Sorry, that's not that one. Or that one. Okay, and then there's oh, 1, 2, 3, 4, 5, 6. 1, 2, 3, 6.
Nice, you got it. Let's go. Yes, and your thought process was trying to find the numbering direction where the substituents will be on the lowest number possible. And when you, especially in the ring, when you rotate the numbering system, you want all numbers to be low as possible. Right. So that's good. You got it. Any questions on that? Any tricky things that you were unsure of here?
Isn't this also gonna be octane?
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4.
Oh, sorry.
Yeah. It
Never
looks like
mind.
octane, but it's heptane. Uh-huh. Nice.
Okay. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know it's nonane, and they're all nonane. And there's 1, 2, 3. Okay, I'll take that one. Okay, they're all 3, 4, 3, 4, 5. 5 is gonna be an isopropyl. Yeah, isopropyl. 5. And 6 has a cyclo thing sticking out from it. So 1, 2, 3, 4. Okay, that's 5.
Nice. You got it.
Yay.
Oh, 1, 2, 3, cyclopropyl. Yes. You see, like once you get to know the rules and everything, like, and you do practice, like it gets like so doable and it kind of fun.
Yeah, it was actually so hard before this tutoring session. Now it's like a lot easier.
Right. I'm glad it's clicking.
Yeah, now I feel like I can actually study for it because before I'm just like, how am I gonna
Like
study this?
overwhelmed. Like what do I do?
Yeah. Yeah, 16 pages of the textbook.
Yeah. Oh no. Now you can practice it.
Yeah. Okay. 1, 2, 3, 4, 5, 6. Okay, so there's a cyclohexane, and then we can go that way. So I have 1, and from 1, I have a dimethyl. Okay, that one has a dimethyl. And then from 2, I have an ethyl, but also from 3, I have an ethyl. And together that's 2 ethyls. So wait, 2, 3 has an ethyl. Okay. And then 1 has a methyl, dimethyl. So dimethyl. Okay.
Yes, let's go.
Yay.
That comes from the discussion manual. 1 is in A. So these are like similar practice that you're gonna see on the quiz as well.
Okay.
Okay, let's go.
Okay. Ooh, the square.
Square.
And then, so cyclobutane makes sense because there's 4. And then I can, well, it's like kind of symmetric, so I can start anywhere. So I have like a 1. Okay. Okay. I think I can say that's a 1. Okay, then that'll be 2. 1, 2, 3, 4, 5. This one is hard to read.
So the cyclobutane, the ring or the square, is the main chain. So the main chain is gonna be 4 carbons long. There won't be a 5.
Okay.
So number 1 could be on the top left corner or the bottom right corner. It doesn't matter since it's symmetrical.
Okay.
So go 1 and then you could go clockwise or counterclockwise. So it doesn't matter as well.
3. Okay. So 1, 2, 3, that'll be dibromo. And then also at 1 and 3, I have a dimethyl. Okay.
Let's go. You got it.
Yay.
I think you thought the methyl outside the square or the ring is part of the main chain, right? And that's why you got the 5 from, like 1, 2, 3, 4, 5.
Yeah.
Yeah, that won't be part of the main chain. Only the ring is the main chain. The methyl is a substituent.
Yeah, I was like thinking like how is the shape made? Like where are the molecules? So that got really confusing.
Yeah. That's good. That's good.
Okay, so that's 1, 2, 3. Oh, okay. 1, 2, 3, 4, 5, 6, and there's 1, 2, 3, 4, 5, 6, 7, 8. So the 8 is probably 1, 2, 3, 4.
Oh, it should be octane. There's a typo.
Okay.
Yeah, it should be octane.
4.
Oh, wait, actually, no. It's actually no name. Yeah, because yeah, I'll give you a hint. It doesn't have to go left to right or right to left. It could start at the bottom or top. Like a substituent it could be part of the main chain. Like something that looks like a substituent.
Oh, okay. Wait, I figured it out. There's that one extra line, yeah.
Yeah, at the bottom.
Like the same because they were like symmetrical.
Right. That's good. Like be careful of that because sometimes like there won't be multiple choice. They actually make you name it, and then like just count from the top or bottom anyway. You know. Like for the quizzes especially if it's written. That's tricky. That's a tricky one.
5 and 6. That's symmetrical. Oh yeah, 4 too. 1, 2, 3, 4. 4, 5, 6. Okay, 5 bromo, 5 bromo, 4, 5, 6.
Yes, you got it. That was a tricky one because of the main chain.
Yeah.
Yeah, let's go. So be careful with that. Be careful of that on the quiz tomorrow or today. You have it tonight?
Okay. I do, but I went to urgent care today, so I am allowed to take it tomorrow or Friday if I want to.
Oh, okay, yeah. Have you done the practice one, the discussion manual or like the second language book?
The second language, I've done the practice, like the one that you do as you read through the textbook, but I don't know if there is practice at the end. If there is, I'll do that.
Oh, okay. That's good. That's good. Good luck tonight. You got it.
Thank you.
And thanks for for promoting the Discord as well. It's so useful.
Yeah,
The roles.
yeah, a lot of people joined, so I'm glad.
Yeah.
Yeah. Also, my name is pronounced as Tanya.
Oh, Tanya.
Yeah,
Uh-huh. Yes.
yeah.
Hmm.
Thank you for your help.
Yep, of course, Tanya. I'll see you. Do you want to have a session tomorrow, or want to continue next week since we had a session today?
We can do next week.
Next week? Okay, let's do next week.
All right, thank you.
Yep. See you, Tanya.
See you.